Alright everyone, here we go. Microbiology, lab, and some lecture stuff. So, I'm not the professor, but I'll do my best to explain these things. A couple formulas important to know when looking at population of a bacteria. Number at a certain time equals the number sub naught, so the beginning, times 2 to the nth power, because it's going to be doubling each time it divides. Now, how are you going to get the n down? You're going to take the log from each side. So log of number at some time equals log of the number at the beginning plus log of 2 to the n. Since they're multiplied here, when you take the log, they'll be added together. Don't ask me how it works. That's just some crazy math. So moving down here, now we're still going to get n down, right? So the n comes down. Then we're going to subtract log of n naught from log nt. So log nt minus log n naught. The n comes over here. Divide away the log of 2, and that'll come over there. All right, if that confuses you, I'm sorry. Just skip it, but hopefully it helps. All right, next, serial dilutions. So we've got a tube here. We're taking 1 ml, putting it here inside 9 mLs. 1 went in for a total of 10. Therefore, 1 divided by 10 is going to be 10 to the negative 1 power. We're going to do that again. 1 ml, 10 to the negative 2, 10 to the negative 3, and so on and so forth. Now, when you look at these plates after you spread them out, too numerous to count for this first one, 730, 67, 5, and 0. Now, when you pipetted from this tube into this plate, watch what she tells you how much you pipette. Because if you're going to pipette 1 ml, it'll be direct calculation. You don't have to worry about the dilution changing. But because she's got 0.1 mLs, that is effectively another 10 to the negative 1 dilution. So your 10 to the negative 3 becomes 10 to the negative 4, which drops in here into your numerator for the dilution. Colony forming units comes from the plate. 67 goes in the numerator. And then times 1 for the volume. And there's that. I put times 1 because I've already taken the 0.1 into consideration. You can multiply it there too and still get the same answer. Generation time, number of generation equals log n at some time minus log n naught. Generation time, so you're going to take your 60 minutes times how many hours, so you can convert it into minutes per generation. And then in the question, I believe it says you've got to start with 4 colonies, and you're going to end up with 128. So you put that in there, you get 5 generations, 24. And that works out. You can double check yourself. 4 doubles to 8, doubles to 16, doubles to 32, so on and so forth. All right, same thing down here. 200 CFU doubles to 400, 800, etc. Generation time is 20 minutes. Time is 2 hours. 2 hours times 60 minutes is 120 minutes. 120 minutes divided by the generation time equals 6. So 6 minutes per generation. And you can check this over here too, 6 generations, 12,800. This one over here is so simple, so don't let her trick you. You're just taking straight up 5 mLs, drop it in this plate. This one you don't have to figure out any dilution because we're not diluting it. So this is irrelevant, not a dilution. It's just the plated amount is 5 mLs. So all you do is just plug and chug. It told you have 50 CFUs, numerator. Your dilution rate is just 1 over 1, or nothing to worry about. 5 mLs because that's what you took and plated. 50 divided by 5 equals 10 colonies per ml. If you find yourself getting tripped up, remember to put the units, and that'll help steer you in the right direction. These other ones are common mistakes. No dilution. That'll probably be an answer on multiple choice, so do not fall for that trap. Another one here, an ml into here. So 1 over 9 plus 1 is 1 over 10. Now we're doing 0.1 into 9.9. So the denominator is still 10, but now the amount that you're pipetting is 0.1. And then what are you plating? 0.1 mLs is actually what's going on the plate. So you're going to drop this into your formula, 220 colonies. That's going to go into your numerator, 10 to the negative third power, times what you plated, 0.1 mLs, is 2.2 million CFU per ml. This last one here might make it a little bit easier. This is the one that Dr. Santisteban actually drew, so it might look more familiar on the exam. So you're taking your sample out of your stock solution, 1 ml into 9, 10 to 1, again, repeat, 10 to 1. This is your dilution, your relative dilution. So each one. Now here, she'll throw you a curveball, 0.1 going into 9.9. So now the relative dilution is no longer 10 to the negative 1, it's 10 to the negative 2. You can plug it in your calculator to double check so you can see it for yourself if you like. And then same thing here. We're doing it again, 10 to the negative 2. Now make sure you keep those things separate. Relative dilution versus total dilution. 10 to the negative 1 for this first one. Negative 1 plus negative 1 is negative 2. Negative 2 plus negative 2 is negative 4. And negative 2 and negative 4 is negative 6. So this plate would have two numerals to count. This one here has 2,000 colonies, 220. Which one would you want to use? Well, you want the range to be between 30 and 300, so you're going to choose this plate. So concentration equals number of CFUs over dilution times the volume plated. All right, hope that was helpful. If you have any questions, please give me an email or swing by Dr. Santisteban's office hours for any clarification. Good luck.